Hello to all my viewers. This is Dr. Dhaval Maheta, and today we will understand how to run lift chart in logistic regression in KNIME. So we go for logistic regression analysis when we are having one categorical dependent variable. The example of this is a patient having the heart disease or not having the heart disease. The independent variables can be on continuous or categorical scale, but it is mandatory that your dependent variable should be in the categorical scale. After running the logistic regression analysis to evaluate its accuracy, we generate the confusion matrix. Now, how to understand this confusion matrix? Let's take a very small example. A person is having a COVID or a person is normal. That we want to detect it with the help of COVID kit. A person is having a COVID and the kit detected it that yes, the person is having the COVID. So 50 are such cases in which a person was actually having the COVID and the kit detected it correctly. Now a person was normal and the kit also detected it that a person is normal. So 114 are such cases in which the detection was again correct. So 50 plus 114 are such cases in which the kit is able to detect successfully. Now let's talk about this six people. They were normal, but the kit detected it that they are having a COVID. On the other side, there were people who were having a COVID, but the kit detected them as normal. So 22 plus 6, 28 are such cases in which are misclassified cases, rather known as a leakage in the model. So our classification accuracy will be based on 50 plus 140 divided by total number of cases. A lift chart, also known as a gain chart, is a visualization tool used to evaluate the performance of a binary classification model, such as logistic regression. The chart compares the predicted probability of the positive class, which we have discussed in this confusion matrix, against the actual proportion of the positive instances in the data set. Lift measures how our model is performing in prediction against the prediction without the model. Let's take a small marketing example. If the overall purchase rate is 10% and the model predicts a certain group of customer having 30% probability of making a purchase, overall purchase rate is 10%, but the model is able to predict 30%. But the actual purchase rate for that group is, uh, just a minute, there is a small correction. Okay, fine. If the overall purchase rate is 10% and the model predicts a certain group of customer having 30% probability of making a purchase, the lift chart would show that the model is performing significantly better than the random model. The lift chart helps to identify the segments of customers where the model is performing well and where it needs the improvement. It also helps to optimize the marketing campaign by targeting the customers who are most likely to make a purchase. Let's take a small example. Here we are having 10,000 cases. They are divided into 10 parts based on the probability, which is 100%. So each part is having 10 percentage probability, 10 percentage. The total baseline probability has been divided into 10 parts, so each part consists of 10% probability. The first part, even in the absence of the model, has 10% probability of any event to happen. It is a ratio of gain percentage to the random expectation percentage at a given decile level. We are considering decile level as we are dividing the number of cases into 10 parts. So it is decile. In the first part, out of 10,000 observations, 877 events have occurred, which is 876 divided by 3859. 876 divided by 3859 will give me 22.7 percentage. The gain for the first part is 22.7 percentage. In the second part, out of 10,000 out of sorry 1,000 observations, 743 events have occurred. So 743 divided by 3859 will give me 19.25. Now, what is the cumulative response? It is 876 plus 743, 1619. Now I can calculate the cumulative gain 41.95 in two ways. The one first method is That 743 divided by 3859 will give me the figure of 19.25. So I will add this two and I'll get 41.95. The gain for the second part is the addition of this. The second method is 876 plus 743 divided 876 plus 743 is 1619 divided by 3859 will also give me 41.95. So this is the gain for the second part. The cumulative lift for the first part is is 22.70 percentage divided by 10 percentage. So the lift is 2.27 percentage. So our model is able to predict the things 2.27 times much better than the 10 percentage baseline. Then let's talk about the second part. It will be 41.95 divided by 20 percentage because it is a second part and I'll get 2.098. In the third part, it will be 55.79 divided by 30 percentage because we are in the third part. Now, how we can do this? Let's see in KNIME Analytics platform. Now, let's activate the input output from here. Read CSV reader node as my data set is in CSV format. Double click on it. I'll browse the data set which is in CSV format. D drive. So my data set is hard1. Press open, click OK. Right click on it and execute. Again, right click on it and see the file table. So our hard disease is a target variable which is categorical, and that's the reason we are running the logistic regression analysis. This we want to do the classification based on age, resting blood pressure, cholesterol, and maximum hours of exercise. They all are on different scales, and that's the reason we will normalize them. So I'll activate the normalizer from here. Right click on it and configure. I'll remove old pick and cholesterol. No, fasting blood sugar. Three types of normalizations are available: mean max normalization, z-score normalization, normalization by decimal scale. I'll request all my viewers to kindly refer my video on normalization. Click OK. Again, right click on it and execute. Now I want to divide this data set into training and testing data set. So I'll activate the partitioning from here. Double click on it. Again, right click, configure. So 80% for training and 20% for testing. Configure 80, click OK. Right click on it and execute. Now, just see the normalized table. It consists of 918 observations. Moreover, age, cholesterol, maximum hours of exercise, and they all have been normalized. Now right click on it and see the first partition, which consists of 734. 80% of the data is in the first partition and remaining 20% is in testing data, 184. So the first partition will be our training data set and the second partition will be the testing data set. I'll activate the logistic learner from here. Right click on it and configure. I'll make the reference category no, heart disease no, so that I can create the model for the yes, because the reference category is no. I'll transfer all other variables this side and only include those variables which have been normalized: age, resting blood pressure, cholesterol, and maximum hours of exercise. Click OK. Right click on it and execute. Again, I will click on logistic predictor. I'll disconnect this from here and connect partition with the logistic regression predictor. So this 20% testing data will enter into the logistic regression predictor, where it will borrow the model from the logistic regression learner, and on that basis, it will do the prediction for the remaining 20% data set. Configure. Click on custom prediction column so that it will create the new column, prediction heart disease. Append columns with the predicted probabilities. We want the probabilities also. Click OK. Right click on it and execute. Again, right click on it and see the predicted data. So here we are having the original raw data, hard disk, and the prediction done by the model with the probabilities for yes and no. Now I want to generate the lift chart. So directly I'll go in lift chart, double click on it. Again, I'll right click configure. So here hard disease is considered. Prediction of the hard disease is yes. Positive labels yes will be considered. And we will divide the data into 10 percentage, which we have already seen. Click on general plot options, show the lift, create image at the output port. Click on it. Click OK. Right click on it and execute. Again, right click on it and see the image. Now you can see that for the first 10 percentage, the lift is more than 1.6. So the red line talks about the lift, the blue line is a cumulative lift, and the green color is a baseline. So wherever the lift and cumulative lift is above the baseline, it means that the model is perfect, is performing much better in these areas. So you can see that till 60 percentage of the cases, 60 percentage, it is performing much better. So here our lift is 1.62, then 1.39, then 1.3, and then 1. Now if I want to have a cumulative gain chart, again I will right click on it, configure, and in general plot options I'll click on show cumulative gain. Click OK. Okay. Right click on it and execute. Again right click on it and see the image. So this will give me the cumulative gain of our model. It should be above the dark black line. And if it is there, that means that the model is quite good in classification. So this is a way you can generate the lift chart in logistic regression in KNIME. For more videos on KNIME, kindly subscribe to my channel. You can follow me on LinkedIn and Twitter. Please refer my playlist in which I already uploaded many videos on KNIME.